Okay, today we're going to be doing the fundamental theorem of algebra. And this is actually something you guys already know. This is just saying that the number of solutions is going to match up or be the same as the degree of the polynomial. So, if you want to hit pause and copy down this definition, this is what I just said. The number of solutions of a polynomial is equal to the degree. And then I kind of included there including multiplicity, so I'll talk about that again. I know I mentioned it before, but we'll talk about that here in just a second. So, again, I know you guys know this. What you guys would do is you would look at the degree of a polynomial. So if it was 3, you guys would look for 3 solutions. Now, multiplicity. What multiplicity is really saying is that when a solution, or it just means that a solution might appear more than once. So multiplicity just means a solution may appear more than once, or appears more than once. So let's say you did a problem and you got x equals 2 3 different times. You get x equals 2, x equals 2, x equals 2. That would just be a multiplicity 0. All right. Now you know that not all of our zeros are always nice. We don't always get answers that are x equals 2, x equals 5. Sometimes we get some ugly ones. And this is where we're going to look at complex conjugates and irrational conjugates. Okay, so I know I wrote theorem there, don't freak out, we're not doing proofs, but a complex conjugate is an ugly answer, same with irrational, so it might just be like 5 plus radical 3, or maybe we have an imaginary number, something like 7 plus 2i. Now, the only way you're ever going to get irrational, these are irrational because it's a radical, or complex, you've got the real and the imaginary part, the only time you're ever going to get those is by taking the square root. And when you take the square root, you get plus or minus. So this is just saying that if you get 5 plus radical 3, you have to get 5 minus radical 3. Or if you get 7 plus 2i, it means that you also have to get 7 minus 2i. So really what this is saying is that these always come in pairs. You get a positive and you get a negative. All right, let's try some examples here. What I'm going to do here is I'm going to give you an example. Or I'm sorry, I'm going to give you some zeros and you guys have to give me a polynomial function. So my directions would say use the zeros. Oops. To write a polynomial function. So I would give you -1, 2, and 4. So really what that's saying is that x is equal to -1, x is equal to 2, and x is equal to 4. Now, I'm going to say that we're going to do a least degree. And you might wonder why I would say that, but that just means that we're going to ignore any type of multiplicity. So I'm just saying that we're only going to get 1 x equals -1, 1 x equals 2, and 1 x equals 4. So if you see that least degree in there, that just means that it's the smallest degree with these zeros. Okay, so we're going to back this, and we're just going backwards. So these are my zeros. The next thing that we're going to look for is we're going to look for factors. So I'm pretending like I had a parenthesis that I set equal to 0. So it's really going to be the opposite of what you see here. So this is x plus 1. So if I were to set x plus 1 equal to 0, let me do this out to the side. If I do x plus 1 equals 0, you subtract 1, you get x equals negative 1. So the factor I would need for x equals 2 would be x minus 2. And the zero that I would need, or sorry, the factor I would need for x equals 4 would be x minus 4. Now to get the polynomial, we're going to have to FOIL this all out. And you've already done this before. So you just pick two of them and we're going to FOIL. So I'm going to FOIL these two first. So I've got x squared minus 4x minus 2x plus 8. Combine like terms. I've got x squared minus 6x plus 8. Then I'm going to bring this one down. And now I'm going to what I call superfoil. If you want to see where you're actually getting this from, I'm going to write down the x and multiply it by this whole trinomial. And then I've got plus 1. I'm going to multiply it by this whole trinomial. Again, some of you guys will just do this in your head, which is fine. I'm going to distribute. So I've got x cubed minus 6x squared plus 8x. Distribute this 1. So plus 1x squared minus 6x plus 8. And then I'm going to combine like terms. So I've got x cubed. I can put together my negative 6x squared and my x squared to give me negative 5x squared. I can put together an 8x and a negative 6x to give me a 2x. And then finally I have plus 8. Now to make this actually look like a function, because it's a polynomial function, I'm going to put f of x. You could put y, you could put g of x. And we just wrote a polynomial function of least degree, so the smallest degree we could have had was 3 because I started with 3 zeros. We really just went backwards from what you guys have done in the past. All right, let's try a couple more.